On April 27, 2011, the United States was hit by one of the most deadly tornado outbreaks in history. 145 tornadoes touched down, including 4 violent EF5s. Hundreds of people died, and the outbreak was one of the costliest natural disasters in U.S. history. Until now, this extreme event has been considered a 1 in a million random occurrence. But our new research shows that tornadoes are not as random as once thought, and large tornado outbreaks are much more common than previously thought. Most forecasters assume that given the right conditions, the number of tornadoes that occur on a given day is just as likely as any other number. We checked this assumption and found that the frequency distribution of tornado days by the number of tornadoes follows a power law. This indicates that tornadoes are not entirely independent of each other. The power law exponent, we find, has a value of 1.64, plus or minus 0.02 standard error. Because the exponent is less than 2, it tells us that average statistics, for example, there are an average of 4.5 tornadoes per tornado day, are practically worthless for estimating the probability of rare events, like the outbreak of April 27th. In fact, the log-log plot shows that the chances of having 145 tornadoes in one day are 0.014%, giving a return period of 71 years. We also find an exponential rule for the number of tornadoes by EF category. For example, on a day where 1 EF5 tornado occurs, there's also likely to be 2 EF4 tornadoes, 4 EF3 tornadoes, 8 EF2 tornadoes, and 16 EF1 tornadoes. Although these statistics are for North American tornadoes, it is most likely that other tornado-prone regions, including places like Argentina, Bangladesh, and Europe, will exhibit power law distributions, though probably with a different exponent, and hence probabilities. This new information can lead to practical measures, such as safe rooms and building codes in areas like the U.S. South and Midwest. In the short term, the results can be used to improve tornado forecasts.